Time to go to the moon, everybody. Title your notes, The Moon. Or Da Moon, whatever. A little bit of history about the good old moon here. The moon goes through its phases in about 1 month, and so its word was derived from the Old English word mona, which meant month. You can go ahead, just write down the first bullet point for this. I'll get some handouts to you here, too. The notes that you take today are very important because Monday we've got a virtual day, don't we? How many of you guys are going to be on senior retreat on Monday? Quite a few people. So I want to make this as painless as possible for you. What your virtual assignment is going to be, and I'll put this on Schoology later, is I want you to take a picture of the notes you take in class today and submit it as an assignment that I will post on Schoology. And that is all. I don't want you guys worrying about this stuff while you're having fun at senior retreat. Yes, we do have a quiz tomorrow. And I gotta say, and I say this in all honesty to you guys, I have never had an astronomy class that has started the year off so strong with quizzes. You guys are lights out, so keep it up. We've got a lot of people that could make it onto that Astronomy 100% club this year. And if we would get I've never had more than one person from one class at a time. But so far, there's a whole slew of you guys with perfect scores. So let's keep it that way. You can write this down too. The surface of the moon is cratered and rocky.
Just that photo?
Do the whole thing, actually. Write this entire slide down. Yes. Sure. You calling me fat?
Did you walk around the whole moon?
I mean, if you had enough time.
How long would it take you?
A long, long time.
Oh.
It is like 1/6 the size of the Earth, but
Okay.
you're still walking a long ways. So, regolith, if you've ever heard that term before, basically means ground up rock. So, when you're walking around on the moon, you're walking through this very dusty material. One of the worries that they actually had before we landed there was people thought that this regolith was so, dusty that we wouldn't actually be able to land, that the spacecraft would just sink down into it and everybody would die. That ended up not happening, so that was good. The surface is terrestrial. All of what terrestrial just means is that you can walk around on it. Eventually, when we get to some of the outer planets, those are no longer terrestrial. Surface features here, you can go ahead and write these down too. Only 2 surface features on the moon. Pretty easy to tell these 2 things apart. You want to land along the plains here if you're going to land on the moon. You don't want to land in a crater. A couple other surface features. You don't have to write these down, but I just wanted to have you take a look at some of them. You've got some valleys that are sometimes between mountains, and you've got some scarps too. Scarps are just very abrupt changes in elevation. To give you a perspective on how close this is to the moon, you can see the, I believe this is the lunar module here that would be eventually descending to the moon. So we'll talk a little bit about that as we go along here too. This is just a map of the names that they gave to some of the larger craters here. You don't have to know these. But this is sort of interesting. When people looked at the dark spots on the moon, they actually used to think that they were seas of water. Go ahead and write down the first bullet point and the second bullet point. You can skip the third one here. Yep. So as you're probably aware, when we did get closer to the moon, we noticed that these are not actually seas of water. Water would not be able to stably remain on the moon. It would all be vaporized very, very quickly. It's also kind of interesting to see different elevations on the moon. When you look at the moon, it always looks the same, doesn't it? And that's because the moon is tidally locked with the Earth. So it's not allowed to spin separate in such a way that we can actually see the other end of it. So, want to know what the other side of the moon looks like? I can show you in an elevation map anyway. This is the side we're used to. Obviously, this is usually gray, and this is mostly a whitish color. This is what it looks like on the other side. So there's a lot more craters, but they're not quite as large. Where's the what's supposed to be? I'm not sure. Maybe you mean like overall when you step back and look at it? Let's see. Anybody see a man somewhere in here? Like from this perspective, you mean?
Yeah, just like when you see up there, you see square.
Huh. I don't know. Anybody pick out a face somewhere? Oh, I can kind of see one maybe. I see like an eye here, and an eye here maybe, and is this a nose? Maybe he's smoking? That's the best I can do. Well, anyway, the moon spins on its axis in 27.3 days, orbits the sun every 365 days. You can go ahead and skip this slide. The main thing you have to just kind of keep in the back of your mind is that it spins in the exact same amount of time that we would measure a month to be. Or roughly the same amount of time. You did. Okay, so the part where I thought the cigarette was is actually his chin. We'll have to check that out again. You can write this one down. The moon is 2,000 miles in diameter, so that's just going from one side of the moon through the middle and to the other end. The diameter? Just by there's a couple different ways. You can figure it out just by actually looking at it in the sky and knowing how far away it is. Then you can use trigonometry and angles to figure it out. And when we actually went there, we were able to get a even more precise measurement. Yeah, roughly 7,000 or 8,000 miles across. So the moon is quite a bit smaller, and this is a proper size comparison. You can skip this one, but you could fit 50 moons inside the Earth. And when I use this analogy here for volume, I mean like you could, like if you hollowed out the Earth and you put a funnel at the top and you ground up the moon into like moon dust, or regolith, I guess I should say, and you dropped it all inside the Earth, you could do that 50 times. Obviously, you could not fit 50 moon-sized objects in there because a circle, you'd have a lot of space when you put circles next to each other. So that number would be a lot smaller. This is just fitting 50 like moon amount of material inside the Earth. That's what that is. 50 moons of material. You don't need to know this number, but again, average density of water is 1. So you can see the average density of the moon is much larger than water. So it is a solid place we can walk around on. How cold and hot do you suppose it gets on the moon? Like at nighttime, what do you suppose is its coldest temperature? Negative 203 maybe? How hot does it get during the day? 125 maybe? You can write these numbers down.
I was 100 off.
I was 37.
The reason you have such a huge temperature variation is because the moon has no atmosphere. When you have no atmosphere, your temperatures can vary a lot. And even if you do have an atmosphere, there's ways that the temperature can change a lot, even here on the Earth. If you've ever noticed during the summertime, if it's clear all day and it's clear all night, it gets pretty cool at night in the summertime. Because without a bunch of clouds up there, you don't have any insulation. And all that heat just escapes to space. If you've got a super cloudy day like today, you're not going to have that much of a temperature difference from day and night because those clouds act kind of like a blanket and they keep the temperature about the same on the surface of the Earth. No atmosphere on the moon, you can skip this, but that's why we've got such huge temperature variations. Yes?
How do you know if it's day or night?
If it's bright or dark. It's either the surface is going to be bright white like this or it's just going to be pitch black. You can skip this one too, but one of the things we look at when we go to these other worlds is we ask ourselves, what do they look like if you look at them through a telescope? And when I say telescope, I don't mean a gigantic observatory. I just mean something like the telescope in the back of the room that I have there by the rocket. Basically, when you're looking at the moon, you can see surface features, you can see depth, and you get those from shadows. This is a picture right here that we took in the astronomy club a couple of years ago. Yeah. And this isn't anything fancy. We just used the telescope and someone put their phone camera by the eyepiece and snapped the picture. So you can see pretty clearly that you can tell that there's, depth here from the shadows. You can see changes in elevation because of that too. And this image was taken by a student who graduated a while ago and went into some astrophysical fields. And he took a much better picture as they had more powerful telescopes where he went. So that kind of begs the question, why did we as the astronomy club observe the moon when it's half lit? Why didn't we go when it's a full moon? Any thoughts as to why that is? Tyler?
The angles of the shadows.
Exactly. So when half the moon is lit, the sun is like up here, and the light is coming down like this. So that means at this point where the sun isn't hitting, you've got all sorts of shadows that are showing up. When the sun comes in at a larger angle, you get a lot more shadows, and when you're looking at the moon through a telescope, you get a lot more depth, and it looks more three-dimensional. If you look at it when it's full and the sun is beating on it from straight up, you're not going to see any shadows. It's going to look more two-dimensional. You can write this one down. Even during the day, the sky looks black, because without an atmosphere, there's nothing there to scatter any particles to make a blue sky or anything.
So can you see like a sunrise?
Yeah, you can see something called the Earthrise, actually. But you would be able to see the sunrise as well. The next picture is actually the famous Earthrise photo. The first time that we went to the moon, we did not actually land there. It was 1968, and it was Christmas Eve, I believe it was. And I think it was Jim Lovell, who was later on Apollo 13, Frank Borman, and I forget the other guy. But they did a circle around the moon because they wanted to make sure everything was working right before they actually went to the moon and landed there and then came back home. And so they orbited the moon on Christmas Eve, and as they were going around the moon, they saw the Earth come up. And they said that was the most powerful experience, that it wasn't actually being so close and seeing the moon, but seeing how beautiful and how special the Earth looked from that distance as it came above this barren landscape. It was really cool. As they went around the moon, they actually read the entire first chapter of Genesis, all three astronauts. They kept it in their flight manuals and fireproof paper. You can go ahead and write down this whole slide. As we go forward with this, and we do this kind of information with all the planets, I just had you write this down now, but going forward, if you want to just write down the percent, that's okay, because I always use somebody who's 100 pounds as an example. So if it was, 85% Earth's gravity, you would feel 85 pounds, and so that would be the same.
So if you would jump on the moon, you wouldn't just like float into space?
Nope. But coming up next, you'll see exactly how high you could jump on the moon.
Isn't it like isn't that why they like attach you to like some rope?
Yeah.
Because otherwise you can literally just like float out.
Well, no, if
No,
you
I'm
jump,
talking about, like, not on the moon.
yeah, like to practice, they attach you with a harness, so you can kind of get used to what that would feel like, yep. 6 times your jump height on the Earth, you can write this one down too. Both parts of it. But like the last one, after we're done on the moon, you probably won't need to write down the second bullet point. You can jump 6 times your height on the moon. You just multiply 6 by however high you can jump on Earth. And 2 feet is about as high as a good athlete can get off the ground. So just think about that. Jump 12 feet, you're on the moon. And that's not from your head. That's the bottom of your foot that's 12 feet off the ground. You could jump over a basketball hoop. Now, of course, they didn't do that when they were on the moon. And they're in these bulky suits. You can't really get a decent jump with those. But it's fun to think about. The moon is geologically active. Not everywhere, just in certain locations. You don't need to write that down. You can skip this one as well, but this is what's going on as you go deeper and deeper inside the moon. The crust is solid, made up of that ground-up rock known as regolith. You got silicate rocks as you get into the mantle, and the mantle takes up a large portion of the sphere of the moon here. And you've got a liquid iron core. When you get further into the middle, you've got enough pressure that that liquid core turns to solid. Yeah, it's super hot. And again, things that are super hot are usually liquid, but because there's so much pressure, it's able to keep it in a solid form there. You can write this down. So the moon does have a magnetic field, but it's very, very weak. It's not the sort of magnetic field that's going to protect you from any kind of radiation from the sun, which is one of the things that we'd really have to contend with if we set up some sort of colony on the moon. You'd have to get protection from that incoming solar radiation, and that's difficult to do over the long term.
So what if you got a compass to
I guess I don't know exactly how the magnetic field of the moon is aligned. If it's aligned the same as Earth, then north would be north, south would be south. I'd have to look that one up. That's a good question. Is there water or ice on the moon? That is a good question, too. Go ahead, write down the... Yeah, write the whole thing down. Water's an important thing. So a question might be, how do you know that there's water molecules so many miles below the surface? We haven't dug down that far. And the answer is it's kind of an educated guess. We do know that the average density of the moon is 3.34, whatever it was, a couple slides ago. And you get that number based on rotation, angular momentum, other measurements like that. And so based on that density, it's too small for there not to be some sort of liquid water further inside the moon. So it's an educated guess, mostly because of the average density that we find on the moon. Ice does, though, exist in craters that are completely shadowed, where the sun never shines. If the sun never shines on there, then that ice cannot sublimate and go out into space.
So
Yeah.
the craters, do they serve a purpose?
Uh,
Or are they just kind of for a little bit?
for the moon?
Yeah.
Well, they're just kind of there. I mean, this would be a purpose. The fact that they're there, and the ones that are deep enough that they have permanent shadows in the bottom, those contain ice. So if somehow we were able to have a colony on the moon, we'd probably want to have it kind of close to some of these craters for some sort of water supply. things hitting the moon. You know, it's the moon. Sometimes we will see occasionally an impact crater occur on the moon. There was one documented in the Middle Ages. It's not the sort of thing that happens on a regular basis these days, but it's something that probably happened a lot more in the past.
There was some volcano.
Yeah, and that volcanic activity was probably more prominent and played a part in a lot of the activity when the moon was getting hit with a lot of those asteroids and making all those craters. Because when the craters go into the moon, it would bring up a lot of that volcanic stuff from underneath. So they probably tie together, but I mean, it's not the sort of thing we're seeing occur now, so it must have happened in the past. But it does still happen now. It's like one of those things that you see in math class where you've got one of these relationships that looks like this. All these asymptotes, right? So in the past, there were probably a lot of meteor impacts, a lot of volcanic activity. These days, it can still occur occasionally, but we don't actively see it occurring on a regular basis. So that's the idea. So from this slide, this is on your handout. What I would like you to point to here is the first bullet point. Put a little star or an arrow next to that first bullet point. Yeah, dash is fine too. Whatever draws your eyes to this bullet point right here. You need to know that you get high and low tides when there is a full and a new moon. And it's pretty easy to see why. You know, everything that has mass has gravity. The moon's gravity isn't as strong as the Earth's. That's why you can jump higher there. And it's less because there's not as much material on the moon. So, you know, water on Earth can flow pretty freely. When you've got the sun here and you've got the moon there, it's going to draw a lot more water in this direction than when you've got the moon up here and the sun right there. Because all this gravity is adding together. The gravity from the sun and the gravity of the moon are acting like as a tag team to pull all of that water in that direction. You get moderate tides when you've got a first quarter moon and a third quarter moon. But as long as you know the first bullet point, you're good to go.
So when the tide comes all the way into the sun,
Yeah, when the tide is all the way in and you have all that water up there, if you're in this location, you'll see a new moon. And if you're in this location, you will not see, you wouldn't see the moon out at all at that point because you're on the opposite side of the Earth. So whether you're on this side or this side, you'll still have a high tide no matter what side you're located on. Because essentially what's happening is it's drawing the water here away. And so then the water kind of gathers, especially over here, but it also gathers on the right side as well. But yeah, if the tide is in, that means you have high water. So then, yeah, you'd be in this location observing that new moon. If you were in this location, you would be observing a full moon if the moon was on that side. So, but either one is if you see a full moon or you see a new moon and you live by the coast, you're going to know because of the tide. In terms of the phases of the moon, I want you to know of these 9, I'd like you to know 4 of them. Know what a full moon looks like. Hopefully you know that. A new moon is when it's not lit at all. You should know that. I would also like you to know that the first quarter is when the right half is lit, and the third quarter is where the left half is lit. And that's the next slide on your handout, the next one down there. So somehow draw attention to the full moon, the new moon, the first quarter, and the third quarter. All right, so there's two kinds of eclipses out there. The lunar eclipse is the one that happens more often. Go ahead and write down lunar eclipse, and unless is this on the handout? No, it's not. Lunar eclipse, and then write down that it occurs when the moon passes into Earth's shadow. The first bullet point. Also, write down that the moon looks red when this happens. Yep, first bullet point and then red moon. And again, to Josh's question earlier, the moon isn't always out at nighttime. It's out during the day sometimes too. So if you've got a high tide during the day or the night, you could see no moon, you could see full moon, or the moon could just not be on that side of the earth either. So seeing what's going on with the moon isn't going to tell you what side of the earth you're on with respect to that tide. But if you do see one, you'll know that the tide's going to be big that night. And this is the sort of thing that a lunar eclipse looks like here. It's not deep red unless the entire moon is in the shadow. And an example of that would be this. Sometimes the moon can look completely red. It did, yep. Sure. Yeah, a lot of times those are really fun to see. They come up above the horizon, they just look enormous. For this slide, go ahead and write down solar eclipse. For this one, do the first bullet point as well. Earth passes into the moon's shadow. The moon is between the Earth and the sun for this one. So again, for a lunar eclipse, you've got the moon over here in the shadow of the Earth. For a solar eclipse, the moon's between the sun and the Earth. And it's just the right size that at a very small location on the Earth, you can just barely get completely shadowed at that location. And I'll have some pictures to show you that. These are some paths that solar eclipses are going to take in the future here. This is the one that came through in 2017. For those of you who were able to see that, I was fortunate enough to be able to drive to a location right about here to be in the full region where you got the full solar eclipse. And 2024 is the next one. So if you're anywhere along this location here, you're going to see a full solar eclipse, as long as it's sunny out. And this would be like the moon beginning to occult the sun right there. And when a solar eclipse happens, it looks crazy. It doesn't look completely dark. It looks kind of like the light that you would see at dawn or dusk, and it looks like that all the way around the horizon. And of course, the sun is going to look something like that. Yeah, because a lot of times they use the moon, they use the sun, they use light, they use dark. It can mess up all sorts of senses that some of these creatures have. That's why birds do get kind of freaked out if this happens. And that's just, I think this is on your handout, another description of what that is. What happens if you land on the moon? This is one of the things that we'll be talking about for every planet that we land on, including the moon here. You can skip writing this down, but it is something to look at. Just read through the sort of thing you're going to go through if you land on the moon without a spacesuit. So what's the question that you might ask regarding all this? Why would you do it? Well, that's a good question. The question I would have is, how the heck do we know this? Well, I don't think we've done this to anybody and asked them how it felt. And what ended up happening is, I know we kind of pick on Russia sometimes because they're always getting hit by comets and meteors and stuff. So in Russia, they have a vacuum chamber, and they had some folks get stuck in the vacuum chamber while it was pressurizing. They figured this out before the guy passed away, but what he ended up recalling, because he was unconscious for a while, they brought him out and they revived him, he experienced these symptoms as he was starting to lose consciousness. Obviously, you can breathe out, you can't breathe in because there's no air on the moon. In 20 seconds, he was unconscious, and the last thing he remembers was his saliva feeling like it was starting to boil. So if you do want to last a little bit longer, if this is you, you'd want to breathe out, because if you have a full lung full of air, the moon is going to take that air out of you through one of the holes of your body. And if you close your mouth, it's going to come out your ears, it's going to come out your nose, it's going to come out your eyes. So if you want to last a bit longer, get rid of all that air, and you'll last a couple more seconds. Or you could just have a spacesuit, and as long as you have eye protection, you'll be just fine. Yeah, it wouldn't be pretty. But yeah, well, you need the eye protection because without an atmosphere, all that light's going to come in and it could hurt you. You can write this one down too. Oh, the real tiny one? We've got super powerful telescopes, and we've been able to see it with those. I'll see if I can dig up a picture online for you. So yesterday we saw that video about the moon and some of the evidence as to why it's young and not old. This is one of those pieces of evidence among many others that I could list. But this is interesting because it's the sort of thing we actually found when we went there. And we gathered these actual examples, this granite that was visible, and we could actually take it out of the scarps, the big changes in elevation on the moon's surface. When we look at those pieces of granite, you can tell that they haven't been around for millions and billions of years. And I do have one more thing I want you to write down. Sorry, just one more thing. I'll get to this later. We talk about getting to the moon a little bit later on. Some more stuff. Last thing I want you to write down is the third bullet point right here. And actually, do the third one. And then from the second one, just write down what I underlined. When you look at the moon in the sky, it appears to be the exact same size as the sun. The exact same size. Of course, it's much smaller, but it's a lot closer to us, so it appears bigger. The sun and the moon appear to be the same size in the sky. Yep. I'll use a darker color if that's hard to see. So quiz on the moon tomorrow. And again, don't lose your notes because that is your assignment for virtual day on Monday.
Oh, maybe. Oh, we quiet. Yeah, put my coat on. I said put the coat up. Oh.